And that's why I buy tickets. It's still possible. I'll be like on my deathbed though. After I've retired, it's like, why didn't you give it to me before I retired? Why do I get it after? That's why God says what? No, Daniel, stop it. He says, stop buying those tickets. You haven't learned. Yeah, I know. Yeah, I don't know. At least who knows? Conditional probability, ladies and gentlemen. This is my favorite. And I have to spell it correct if it's my favorite. So I have to stop. I have to focus. What? Ability. This is my all-time favorite definition. Give you guys this amazing definition of conditional probability. Now, this probability very often is used. I haven't given it to you yet, but it's used to compare groups. Mutually exclusive groups. Okay. Like, for example, you might say, what does that mutually exclusive idea really mean? You guys know. It means the intersection is empty. Technical definition. It's kind of like if we compare men versus who? Women. They're mutually exclusive. Meaning, if I list all the men and I list all the women, you're not going to find a single person on both lists. You can actually compare different groups. Like, for example, I would say, well, boys versus girls. You know, this is kind of always a good thing to do. Women, let's say under 40 versus women maybe at least 40. Okay, there's nothing unique or special about women under 40 and women at least 40. This is defined any way you would like. To compare groups, we can compare, for example, Latin versus maybe Asian. Okay? Versus. This is the versus. So let me, instead of abbreviating, do you guys know what does versus mean? Yeah. Do you guys know what I mean? So we like to compare different groups. Like if I said to you, who's more likely to smoke cigarettes? Men or women? Don't know. We can collect data and we can use this conditional probability. Who's more likely to drink a martini? Men or women? Traditionally, a martini was what? Smoking and drinking martinis traditionally were exercises that men did. We can compare these probabilities. Do you guys know what I'm saying? We can even compare probabilities. We like to compare who? Like here's what I'm going to use a different color. Men, boys. These are the two different groups if you want to think of it that way. But it could be more than two groups. Okay. Who's more likely to cheat, men or women? Got to gather the data and compute the probabilities. You guys know what I'm saying? There's an issue, though, with gathering data. What's the problem? People don't always tell the truth even when you gather data. Do you guys know that? But we can try. We can still try to do that. But all I'm just trying to say or trying to do here with you guys really is this. Pique your interest with what definition? Conditional probability. My favorite. Love this definition. I can love it because it's very powerful. Used to compare groups. Okay? So let me start to give you that definition. You're going to see the phrase. Well, let me write it down. Conditional probability. This is the probability of A given B. This is the phrase that we're going to see. The probability of A given B. So first of all, it's a probability question, and it's a probability of this event we call A. But then you say, well, what about this phrase right here, given that? And I want to do given that, not just given that, because that's how you usually see the word. This is really the tip-off. Given that B has occurred here, okay? So we're gonna talk about that. Here are the symbols. Probability of A. You might say, I already know. There's that parentheses. This line is given that. This is the condition called B. Okay? So let me color coordinate this. This is my event. This is a probability of an event there. Symbolically, this line means given that. And then this purple means what? B. This is, we're going to call it, that's called the condition. The condition here is known, or it has happened. So you guys ready for the definition? It's very simple. It's not that hard. It's the number of A and B divided by the number B. On the right side is the definition. So over here we got A. Here's my condition B. It's no longer N of S, it's now N of B. And then we have the word and. I think we use the color green for that or something, right? Was it yellow? Oh, you're right. It is, or is orange. Whatever this is. This, ladies and gentlemen, is the conditional probability definition. This is gold. This is used for comparison. And you say, what is used for comparison? The right side over here, that's your conditional probability. So write that stuff down. Probability of A, given that, condition B, it's known, it's happened. That's a very powerful statement. Used all the time. So let me share with you guys my ultimate favorite setting to start the conditional probability examples and discussion. Okay, you guys have that in your notes? Okay, so go back how we started the day. You know how we started the day? Talking about the Titanic. Favorite setting for this definition. You know what's nice about this? People study this table. They study the table. They try to figure out a lot of things about society. I have seen this table used. There's a lot of other detailed table too. But, you know, I've seen people look at this and say, is chivalry dead? You go, what are you, Titanic and chivalry? Yeah. Yeah. There was, I forget what it was. There was a setting somewhere somehow. People want to know if chivalry was dead, and they look back. Because when did the Titanic happen? Was it like 1914 or something like that? It's like 1914 or something. I could Google it, find out. It's over 100 years ago. Now, what do I mean by is chivalry dead? We want to know the following questions here, okay? Here's what we want to know. If you select a person at random, what's the probability the person, question 1, survived, given that the person was a what? Man. Okay, you guys okay with that? Question number 2. Compare that to the probability the person survived, given that the person was a who? Woman. This is interesting. Why is this so interesting? We're comparing the survivability rates between two different groups of people. Who are they? Men and women. Yeah. Who's more likely to survive, men or women on the Titanic? This is what I'm getting at. Okay, you guys okay with that? This is why people start to study these kind of tables here. These are examples of conditional probabilities. How do we know? What does it say? Probability you what? Survive? What's this phrase? Given that. You see this in your mind, what do you think? Conditional probability. What's the condition for this first question? Nope. You're a man. The condition always comes after the phrase given that. Right? Go back to the definition. You see how I gave you that here? It says the probability of A given that what? B. The condition is in purple. It comes after the phrase given that. Okay? The A, the first one, that's like regular probability. So we're comparing. What's the next question? Chance you survive. What's this? Given that, what's the condition now? You're a woman. We want to see who is more likely to survive the Titanic. What do you think? Women? Why would you say women? Very good answer, although that's not correct. It doesn't matter what the population is. You guys are going to see that. But what? It's okay. It's okay. It's okay to be tired. I had an extra cup of coffee today, so I'm good to go. Okay? We're comparing who's more likely to survive. Why do people think women are more likely to survive? You're answering based on a comment I made. Is chivalry dead? What was the statement years ago? Maybe you don't know. People used to say, women and children first. What does that mean? They mean save the women and children first. Why save the women and children first? You guys know why? Why would you say save them? There's actually probably a good anthropological reason. You know why? I'll tell you what I think. If I were ever asked that question on a thesis and I had to write a paper. Yeah, I know. Tell me. Now you don't like English. Yesterday you loved English. Remember, write a paper on Fluffy. 20 pages. If I had to describe a paper on that statement, right, why do I think women and children first? It's kind of what I talked about yesterday. You see, in some sense, women and children are the future of mankind. In some sense. You say, well, not necessarily men. Well, I mean, yes, you need men, but you don't need a lot of men. See what I mean? You need the children for the future. You need the women for what? More children. So you can kind of get away with having less men, in a sense, to repopulate the world or the town or whatever. You guys know what I'm saying? It becomes problematic. You can't have just one guy and like 20 women because that's an issue. It is an issue biologically as well. You guys know what I'm saying? It's an issue. So, but you don't need as many men. But you do need the women, you need the children, and that's still good to go. Okay? You guys, you see my point? And that might be where and how and why that statement exists. Maybe. Maybe there's another good reason. But saving women and children first. So this is kind of why that Titanic table is studied, because they can start to analyze, did they believe back then in 1914, women and children first? Let's see. So the conditional probability definition, here's what you're going to write down. Probability you survive, given that you're what? A man. You guys see why I did it this way here? Even with colors? Because this is what? This is the event. What does this line mean? Given that, what is this? A man. So ladies and gentlemen, you got to look for the number who survived and are who? Men. Not divided by N of S, divided by the number of men, because this is the conditional probability definition, ladies and gentlemen. So let me color coordinate so you guys can see it. Orange, I think, was the and, okay? So it's going to match exactly what we have up here. Double check. Double check that even the colors match. See why I do that? So again, all you're going to do is look for two numbers. A numerator and a denominator for this definition. Just two numbers. Let's see if we can find it. I might go out to Microsoft Excel. Let's see if this thing even remembers. There we go. It did. Okay. What's the numerator again? They're looking for the survive row. And I'm going to have to undo that. That's not what I wanted to do. The survive row. I don't know what color. Survive row and the man column. What number do you see there in survive row man column? 300 and what? 32. Okay, you guys okay with that? 332. So that's going to be my numerator. You say, why is that the numerator? Because that's the survive row. And remember that and? Ashley, you go to Disneyland. If you clean your room and eat your vegetables, both things are satisfied. Survive row, man column. That's 332. All right, you guys okay with that? You're just using your definition. What's the denominator? Don't say 2,223. That's people are gonna. How many men now? So you're really looking at, of all the men, how many men now are in that table? 1,600 and what? 92. So they're really saying, of the men, don't consider everybody now, just the men, how many survived? 332 out of 1,600 and what? 92, ladies and gentlemen. So I'm going to go back. I got to go to the iPad just to kind of share with you guys that fraction here, okay? That's really what you're doing. That's really what you found. That's 1692. So we want 332 divided by 1692. So in the TI, 332 divided by 1692. Go to the nearest thousandths again, and what do you guys get? 0.196. Is that true? Okay. Now let's look at the answer. Okay, that's your answer. And that really corresponds to what? 19.6%, right? So what you guys can do is you could go home and say to people that you know what the chance of surviving the Titanic when you are a man? It's about 19.6% chance. It might be, we'll see the numbers. And what I show people after we see the numbers, I say to people this, does this exist over 100 years today? You know, when you see these, let's look at the numbers first. So the chance you survive, look how I'm reading left to right. Probability of surviving, given that you're what? A man, you got like a 19.6% chance of surviving that Titanic. Let's compare that with the chance of surviving for women. Okay? So you say, how do I do that? I use my definition. Probability you what? Survive, given that you're a woman. I'm going to color coordinate this. Chance survive. What does that line mean here? Given that you're, what's the condition? You're a woman. Number who survive and are women out of the total number of who? Women. So you know what? Now we got to consider this. Of all the women, you're going to look at a different group now. You're going to find of all the women. So you got to know how many women are on the Titanic, right? How many women survived? So I'm going to go to Excel again, and I'm going to get rid of this stuff that's already there. I think I can undo. I'm still on survive, but this time, what's the group? Women. Oh, survive went away. It's better if I do it this way. Yeah, what number is that, ladies and gentlemen? 318, what does that represent? The women who survived. It's both and. How many women were on the Titanic? How many women are there? 422. You guys okay with that? Okay, so 318 over what? 422. I wrote that stuff down. Remember, it doesn't have to be the same size. Yes, there's less women. I mean, there's a lot more men, but there's less women. But this ratio, 318 over 422, we're going to compute because this is a conditional probability now. So we're going to go to the TI and we say, okay, 318 divided by what? 422. And what do you guys get here? What is it? 0.754 what? 4. Is that right? 0.754. So let's think about what this means again. This is the probability as a percent. You know what that is? Yeah, 75.4%. So ladies and gentlemen, let's consider this here. The chance you survive, given that you're a who? A man, is 19.6%. The chance you survive just by changing your gender is 75.4%. What does that mean, ladies and gentlemen? Well, it means, let's note. This is usually the question I ask after, right? The question I usually ask is which, I don't know if it's sex or gender, who knows, which gender is more likely to survive. Okay? Because it's not just I want people to compute a value, I want them to know what it means. You want to use it. So, what does it mean, ladies and gentlemen? Who is more likely to survive, men or women? How do you know? How do you know women are more likely to survive? Yeah, because the probability is greater. Remember those definitions I gave you yesterday? A greater probability, ladies and gentlemen. So women are more likely to survive. What that also means, by the way, we can say this comment. Men are, we'll just say by the way, men are less likely to survive. And of course, that's on the what? Titanic here. Okay. So, you say why? Well, because the probability is smaller. Okay. 19.6 is smaller than 75. 19.6 is smaller than the 75.4%. And that's really what you're comparing as those inequalities here. So, what do you guys think? Is chivalry dead? Is it 1912, the Titanic, 1912? Would that happen today? If, let's say, you were on a cruise ship to... Anybody ever been on the cruise ship to Ensenada? You guys know what I'm saying? What if you hit an iceberg? What's going to happen, ladies and gentlemen? Or is it going to be women and children first today? Would it be women and children first, or would it be the strongest first? I think it's going to be the strongest first. Do you guys know what I'm saying? I don't have any data to support that. That would be a whole other topic. I don't know. Don't have any idea. What's the probability to survive given that you're a boy? That's question 3. Question 4. What's the probability to survive given that you're who? A girl. So I'm going to have you guys try this out. Okay? See what you get. And of course, we'll go over it. Okay, let's try to see if we can answer these questions. Let's see if the children fared any better. What's going on with the children here? Right? These are conditional probabilities, and you might say, how do we know that? How do we know they're conditional? The phrase given that. Yes, that's how we know. And what always comes after that phrase? What always comes after? The condition. Yes. Here's the first condition. You're a boy. Second condition, you're a girl. We're going to use those definitions, okay? So I'm going to move this down here. And now I'm going to write this down in terms of our notation, okay? So probability, you what? Survive. That vertical line means given that, you're a B. The definition, number who survive and are boys divided by the total number who are what? Boys. Okay. You guys okay with this one? Now, if you want me to color coordinate it, I will. It's very helpful, I think. So you guys can see all the details. So I need two numbers here, right? I need how many who survived and are boys out of the total number who are what? Boys. So let's go to that Microsoft Excel. So what are we looking for again? Do you guys know? So we're looking for the survive row and what column? The boy column. How many boys survived? 29. Good. And how many boys are on the Titanic? 64. Outstanding. Okay, let's go to the iPad so we can see that written down. So you guys are going, okay, 29 out of 64. Let's see what this is, approximately. TI. So this is point what? 4, 5, what? 3, okay? To the nearest thousandths. Now, what does that mean? This is a probability answer, so we're good with this answer if they ask us. But when you have conversations, we very often use the what? The percent language, okay? Because people are more familiar with that. So this means 45.3% of who? The boys survived, okay? So the chance that you survived, as I read it left to right, probability of surviving, given that you're a boy, you got a 45.3% chance. Okay? So, I don't know if you said, do the boys fare much better? Well, they're better than the men. Is that true? 75%. Well, let me take that back. What's the probability? Well, they're better than the men, 19.6%, but they're not as good as the who? Women. So far, the women are the most likely to survive. Well, let's see about these little girls, right? These are the boys. Let's hope the daughters fare better. What do you guys think? No? You don't want to save the daughters? Given that you're a girl. Yeah, remember, this is kind of like not a real what? Nice topic. You guys know what I mean? It's a bit. But it's almost like, it's like, this is kind of one of the reasons why people didn't like to read the news. Always bad. People get depressed by reading the news. You guys know what I mean? Or watching the news whatever that is. I read a nice thing the other day. The ozone layer is closing. That's nice. That's a good one. That's a cheerful one, right? You guys know what I mean? It's over the news. The ozone layer is closing because there's a hole in the ozone, and it's taking a long time to close that thing. But it's closing. So that's great. You guys know what I mean? That's good. That's some good news. Nice. Okay, let's go to Excel. What are we looking for now? Of all the girls, right? So we got to look for the girls now. How many of the girls survived? So let me go to the Excel spreadsheet. Undo. Wait, undo. So now we go where? The girls. Remember, it's still survive and girls. That's your numerator. How many girls survived? 27. Of the 27 that survived, out of how many girls? So it's 27 out of the 45, okay? So, okay. Let's see that fraction. 27 out of 45. Okay, it's there. Let's go to the TI. .6, and that's equal. So that's equal to 0.6, okay? That's equal to 0.6. Let's go to the iPad there. What is 0.6 as a percent? Remember, we want to communicate. This is what? This is 60%. So, ladies and gentlemen, this is some good information. Okay. So the good news is, let me read it left to right. The probability or the chance of surviving, given that we are talking about girls, they have a 60% chance. 60% of who? The girls survived. So you were more likely to survive if you were a girl than if you were a what? Boy. Higher probability value. You're less likely to survive the lower probability value if you're a boy over being a girl. So this is how we start to compare probabilities and groups of people, which gives you some very powerful information. So today, what do you guys think? Who do you think might be more likely to survive today? Don't know. Yeah. In that Titanic, if the Titanic floated today with today's, what do you call them? With the standards of today. Don't know. Don't know. I don't know. It's hard for me to say. I don't think it would be so easy to say, hey, women and children first, though. But I don't know. Well, stop and think about you. Cold ocean water in the night, iceberg, getting on the boat, survival. Are you going to say, hey, stop, women and children first? Probably not. I don't think so, but I don't know. I could be wrong. Maybe there's laws that require, you guys know what I mean? They require a greater number of lifeboats than passengers, or at least the same number. I don't know. I'd have to check with anybody likes going on a cruise. Check with the captain. Is that right? Hey, captain, do you have enough boats for all of us? They might say, no, we have enough life vests for all of us. The problem with the life vest back then is if you're in the water, you probably freeze to death. I don't know how much time you have until you freeze to death in icy water. Mm-hmm. You guys know what I'm saying? And then what about sharks? Sharks don't care? They don't care if you're frozen? Do you guys ever think about that stuff if you go on a cruise? I don't even like cruises, so you know what? I don't care. I don't like cruises. What's that? Yeah, but will you be on a plane? No? You you don't like flying? Well, nobody likes flying, but you still do it. You wouldn't even get on a plane. So you're going to Hawaii? Yes. In fact, that plane last night, you guys seen the LAX? What's going on with that Hawaiian Airlines plane? I don't know. There was something about a Hawaiian Airlines plane. I know my wife was going, "What's happening with that Hawaiian Airlines?" I go, "I don't know. What happened to it?" So sounds like a glitch, but the plane landed, right? I gotta look into it. I gotta find out. No, no, I'm talking. Okay, that's something different. This event happened last night. Sounds like there's another. So on Netflix, there's a documentary on what? Oh, the Boeing 727. I gotta watch that. I'm gonna. Thank you for letting me know. I gotta. I don't. Don't know. All right. Interesting. 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 Anybody ever been infected with cooties? You ever get cooties? You ever get any cooties before? Only boys have. I thought cooties was a girl thing. You got cooties. You guys remember that? Cooties growing up? I don't know. I didn't even know what cooties are. You just were afraid of cooties. You're afraid. Well, take a look, ladies and gentlemen. This is a very good example that we're going to start, you know, let's give you guys a couple of definitions here, okay? I just want to talk about this table because with this class, there's expectation that you guys know a little bit about this kind of thing. Whether you're a student, a community college student, or even a human being, these definitions are out there that you want to, not cooties, but anything. You can be tested for anything. You can be tested for, they used to test for marijuana. You could be tested for a pregnancy test, diabetes, any medical test. It has what's called built-in errors. Okay, you guys okay with that? Let me emphasize that here. Any sort of biological test has these things called built-in errors. So you want to know about those kind of things. It's like the error rates. You guys know what I'm saying? So even if you did, even if you ever been tested for, took a pregnancy test even, or a COVID test, or anything. Well, in a pregnancy test, if you read the box, anybody ever everybody ever read the box of a pregnancy test? Yeah. Yeah, you guys remember that, reading that stuff? Guys, who's done that? Anybody know? Only a few of us? Three. You guys might want to, it should probably give you a like homework. Go to CVS. Read the back of a pregnancy test. Yeah, they do. They do. They keep a lot of things locked up. It's horrible. Horrible. Anyway, we have these very special definitions that I'm going to give you guys in the future. You'll see that. Let's go to the browser, okay? And I'm going to give you the link here, but we're going to work on these probabilities here. It's a conditional probability. So I wrote a whole bunch of stuff back in the day. Let me find it here. Where are you? It's under conditional probability, so you guys know. And, I wrote some things that were in a statistics manual somewhere, blah, 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 blah. And I actually used COVID at the time. This is when we first got shut down due to COVID, right? We first got shut down due to COVID. So I kind of wrote some of this stuff because and I even said this is fiction. Data's not true. Just made up some data. Okay? But the point I want to really make is you might notice, infected, not infected, test positive, test negative. You guys know? And then there's a bunch of questions here. I gave people back then the definition of a conditional probability. Same thing you guys have today. But here's what I want to get at. There's something called a false negative. So we're going to look at some of those things, false negatives. You go, what in the world would be a false negative? Well, it's very simple. A false negative is essentially a test result that incorrectly indicates a person does not have a particular condition. So you could get tested, says you're fine, but you're actually what? Infected, yeah. It's called a false negative. In other words, we can compute the probability of a false negative. That's the probability you test negative, given that you are actually what? Infected. And those are the things that we're going to do. Okay? You also have something called a false what? Positive. Okay? This is what I was getting at in those pregnancy tests. It can falsely say you're negative, and you might celebrate. Like, yay, I tested for pregnancy, came out negative, but you're really what? Pregnant. You can have a false positive. You say, what's a false positive? Well, that's when, I think this is good. We're going to compute what's a false, it's a test result that incorrectly indicates a person has a particular condition. So we can compute the chance of a false positive. That's when you're really not infected, but you test what? Positive. Those things happen. False positives can happen. That's referring to your test result being positive, but you're not infected. False negatives can happen. That's what we're going to compute. And that's actually, it's not a fixed rate. So you can get tested for diabetes. There's a false positive rate. You could get tested for being pregnant. There's a different false positive rate. You could get tested for marijuana. There's a false positive rate there. So it's unique to the test. Okay? So don't think that, that rate is a fixed given rate for everything that you ever get tested. And that's not true. There's also things called think I gave this to a true positive and a true negative. Well, that's kind of makes them. A true positive is, well, you are infected and the test result indicates you're such. True negative, well, that's a negative test result and, indicates the condition is not present. So I made this worksheet for people because they're like test questions. I always give those kind of test questions because, like I said, it's not just, ladies and gentlemen, nursing majors that care about these kind of things. If you're a person that gets tested for anything, which we all do, we care about false positives, false negatives, really. I mean, you might say, do we care about true positives and true negatives? Not really. They are there in like nursing major books and blah, blah, blah. But it's really the false positive, false negative you ultimately really care about because, it's an incorrect diagnosis. Okay, so we don't care, well, we do care, but we're going to care about the incorrect diagnoses here. So this is a different example that I made. Fictional data, okay? But you have those definitions. If you want to read that, you certainly can. But I kind of made this infected with cooties as a different example. So you have a wealth of examples. And of course, we're going to use that conditional probability as well. We're out of time, though, unless you want to go through it. What time to get out of here anyway? 40? Oh, we got a couple of minutes. Here we go. So we're going to look at this here. For example, this is going to be the cootie data. Okay? Cootie data. Can't see it. They're going to want to know the false positive rate. Okay, that definition, that's the probability of testing positive given that you are not what? You're not infected. Okay? This is for the cootie data. Huh? Yeah, this is the testing. This is your event. What's the chance you test positive? But what's really known? What's known is you're not what? You are not infected, ladies and gentlemen. So the test result is indicating something that's not happening. You also have the definition of a false what? A false negative. And that's not rata, that's rate. So the next time you guys look at that stuff, or you get tested anywhere, you guys want to ask the doctor these questions. That's a chance you test negative, but you're actually what? You're actually infected. Let me go over even the language, okay? Because it's kind of tricky. Test negative, given that you are actually what? Infected. So remember, this is the condition. This is the thing that is actually known. You're not infected in the first case. You are infected in the second case. Well, let's go through that and talk about this because this is kind of something that people look at and they go, how in the world does this even work? Here's the reality. What you guys see in the table, the data in the table, the cootie data, people were tested twice. They weren't tested once. They were tested what? Twice. So that's how they're able to say, okay, we know somebody's infected. We know somebody's not infected. And this is their initial test results, test positive, test negative. So what they don't tell you with this all the time, with these tables like that, when they gather the data, people are tested more than once so they can verify. Okay, so that's kind of how that works. Now, using this, yes? Just want to know, is the outcome the same or does it vary? No, it can change. Yes. That's what we're finding. The errors. And that's the whole point. You go, wait a minute. Because it is a little confusing. When I first read this stuff and thought about it when I was a student, I go, how in the world, if I'm infected, how in the world can I test negative? You know what I mean? That's impossible. Well, no, because the testing procedure format, whatever it is not perfect. There's human error. There's error in the testing material. It's not 100% guarantee. That's the point. That's the scary thing. That's scary. So it's like if you ever taken an AIDS test, right? I've taken an AIDS test. It came back negative. So like, yeah, but you want to know the reality of it? It's not a guarantee. I could have been HIV positive, but my test result's negative. That can happen. The reverse can happen too. It can come out that your HIV test is positive, and you go, oh no, I got a positive test result, boo-hoo, right? But there's a chance that you're not really infected. Think of it that way. My test result's positive, but I am not infected. That test result is no guarantee. The positive test or the negative test is not a guarantee of your condition. And that's what we're really talking about. There's these false indications. There's the errors. So even if you went to the doctor and you said, okay, I took an HIV test, and the doctor, here's what really happens in case you guys don't know. What really happens is, if you've ever been tested for this, I have. And they tell you this. The doctor or the nurse, whoever does, they say, okay, if your test result is positive, we'll give you a call. If your test result's negative, well, we're not gonna call you. You guys see what I'm saying? So you go in. Anybody here get tested for HIV? Yeah. Isn't that kind of how that works? You guys remember? So what happens is, if your result becomes positive, they call you. You say, why do they call me? Because they want to retest you. They're going to give you another test just to make sure. That's the errors we're talking about. So they'll retest you, and they're going to try to double check. Double check to see if the first result matches. So that's what we're talking about. The scary part, though, is if you test negative. Why do I say it's scary? You can test negative, and you go out and you celebrate. You might actually be what? Infected, but they don't double check the negative test results. Yeah, it's expensive. They do it. They really do it, in all honesty. You say, why would that be? It's efficiency, and it's probably every test has an expense. So that's the thing I thought about. I go, wait a minute. So if I'm negative, you're not going to retest me? No, I can still be infected. Yeah. Weird. That's what we're referring to in this table here. Okay, so we're finding the errors. So yeah, there's some errors there. We're going to compute them. I use cooties because, there's no such thing. And it doesn't freak people out. Cooties. At least it shouldn't, unless there's something really wrong with you and you think, no, Mr. Judge, I've had cooties. They'll say, are you sure? Yes, I'm that cootie person that they're referring to. There's no such thing, okay? And again, I made up the numbers. So we'll compute those things tomorrow. False positives, false what? Negatives, okay? All right, so let's look at your homework here and find out conditional probabilities. Let's go to the browser. It's that time of day. Yeah. It's kind of scary if you really thought about it. Very scary. Addition rule, complement rule, conditional probability right here. Statistics lecture number 6. Yeah, reality is not that fun. Yeah, this is one of my favorite topics in statistics, really. It helps you with that critical thinking, in my opinion. They what? Conditional probabilities? I don't know. High school, like I said, was kind of what? High school. Okay, you guys. Where's our... All right, statistics lecture 6 there. Take care, stay safe. We'll see you when? Tomorrow.